Alright, you guys, welcome to day 13 of Advent to Code. I'm late. We're going to get started right now. Let's do this thing. Let's go ahead, copy your input in. Oh, this looks fun already. I'm losing everything track. Okay. Oh, there's a oh no, this is going to be painful maybe. You're reaching a little volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you're greeted with congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual. Apparently, the elves have never used this feature. To your surprise, you manage to find the manual. As you go to open it, page 1 falls out. It's a large sheet of transparent paper. The transparent paper is marked with random dots that includes instructions on how to fold it up. Your puzzle input, for example, first section is a list of dots in the transparent paper. 0, 0 represents top left corner. Yeah. Downward. So yeah. And there's a list of fold instructions. Each instruction indicates a line in the transparent paper and wants you to fold the paper up for horizontal y equals 0 lines, or left for those. In this example, the first fold is fold along y equals 7, which designates the line k. Interesting. 3 bigs. For now, just focus on completing the first fold. After the first fold, in the example above, 17 dots are visible. Completed constants. How many dots are visible after completing just the first fold of the paper? Okay. So, how are we gonna parse this? What's the input? So these are coordinates. Okay, so we're gonna do this. We're going to do for string s in inputs, and what we're gonna do is we're going to do a check if string is empty. We are going to break out of this and skip ahead. So this is just taking care of this. Okay, so Boolean, this is going to be the dots. Yes, and it's going to be input dot size. I'm gonna hard code this. Oh, this doesn't even say. Okay. Oh, this doesn't even say how big it is. We could do a list of a list, which works, but not ideally. How do we want to do this? I guess let's bring back our fun points. Where was point last used? Here. Yeah. Okay. Let's bring back our point here. We're gonna do a list of points. This is gonna be the dots. Okay, and then we're gonna go here, and so we're gonna do then. We're going to have to split this string up on the comma, I believe is what it is. Yeah, so the comma. Equals s dot split on the comma, and what we're going to get now is a new point. P equals new point integer parseInt 0. This is the x. It's actually xy. This is backwards because xy is going to be column row. So that goes row column. There's our point. So we can now go to dots and we can add p. Good. Now we can't do this. Actually, no, we can do Boolean. We can do loading points. And we actually do here is set this to false then. Continue, and we can just do a check here for loading points, do this logic. Otherwise, do this logic of actually folding it. And we're gonna break after this one because we're only do it once for the first part. And we need to fold. So if we're folding along x equals 655, we're going to need to parse this. How do we want to parse this? We're gonna have to do parts s dot replace this annoying, get rid of this because we don't care about it, and then split on the equals because that'll give us our two parts. And now we can do a check here if parts 0. I know this is always going to be x for the first part. We're going to do both of them here just because. If it's x, we have to go through, draw that line, and do whatever. So that means if it's at 656, it's going to go to 654. So what's going to be coming is int line is going to be at integer parse int parts 1 parts 1. So there's our line, and what now we need to do is go through all our points. So for int I equals dot size. Actually, let's make this a set because we can only have one point, so that way we won't have to deal with this, and that means we're actually going to need to do the equals here. So let's go ahead and add this on. That way the hash and equals are there. That'll do all the logic for us, which is good. -1 while I is greater than or equal to 0, I minus. And then we can now go ahead and do the logic. So what we're going to do here is we're going to do point p equals dots get, nope. Oh, right. All right, nope, we can't do a set. Sorry, we gotta do a list because you can't iterate really over a set like we want to do here. So we're gonna do this. So dots, no, not remove. Nope, just get I. And so now we gotta do if p dot column is greater than line, what we need to do is change this p column. You do p dot column is going to equal p. It's going to be subtracting minus line, because if it's 1 over, we need to go 1 less. No. Equals line minus that, right? Yes. And then now I need to check if dots how do we want to do this to where we can avoid duplicates? Let's do this. Let's do if, so it's gonna be int new x. This will avoid that issue. So now we can just do if dots dot contains new point at p dot row new x. If it contains it, then we can go ahead and do dots dot remove this one, which is actually going to be I. Otherwise, or we could always remove it. Now let's just do, no, that's fine. Otherwise, set this one, we're good. That's it. Okay. Again, not needed to do this. We'll just leave it like that, actually. And then we'll call lap of dots dot size, shall we? Let's see, did we do this right? Hey, we did do it right. Sweet. Here, part 2. Finish folding the transparent paper. Is always 8 capital letters. Okay, so we do need to finish this. Okay, so we got part 1. Good. Now we need to do this. So now this is going to be all row work. Row. That's going to be column. That's going to be row. That's going to be new Y. New Y. P dot column. Row. So that should, in theory, be good now. So now no more break is needed. That's probably the one exception. Okay, so we can now do the entire thing. The only issue now is outputting. Dots int max, let's do max column equals dots dot max p. So let's just do this. Nope, that's not JavaScript. Max column. What is this? Oh. Right, that's what it wants, and it's going to want then and then get. All right, screw it. We're gonna do this. We're gonna do this the long way. Max column equals -1. We're just gonna do this the not fancy JavaStream way. And then max row is gonna be that, and then we're gonna go through point p in dots, and we're just gonna do check here if p dot row is greater than max row. And then likewise for the column. Okay, and then now we're just gonna build up a string here. So so for int row equals 0, well, row is less than max row, row plus plus. Actually, it's gonna be less than or equal, by the way. And then do the exact same thing for our column. And max column. And so then here we're just gonna do a system.out.print. This will be the print line. The print will have dots contains row column. If it does, output that, sure, otherwise nothing. Whoops, otherwise nothing, and we should, in theory, run this. Oh my goodness, it actually works, but I can't. Oh god, that's not easy to read. UCLZRAZU. Hey, we did it! 367, not bad. That was actually a pretty good one for me today. 397, 367. Not bad, not bad. So, there we go, day 13. As always, the past ones, let me go through, clean up the code a bit. I might try and break these off into separate parts like normal. Actually, I will do that because I know a way I can do that. So I'm going to clean this code up, make this a little bit easier, and then I'll come back and I'll explain my solution. Okay, code's cleaned up a bit. I went through and also made this a little easier to read by using these full Unicode block characters. It's a bit easier to read. It's still not, it's better than what it was. Go with that. They also added part 1 and part 2 both here. They're just kind of all together. You'll see in a second here. So, at any rate, day 3 is basically we are given this. Our input is a bunch of points that are on an imaginary grid, and the problem is asking us to fold this imaginary grid along certain lines. And at the end of it, we will reveal what I just showed, which is a 8-character or 8 letters in a sense. And so the way we go about doing this problem is we are going to have a list of points. By the way, I moved point. We've used a point a bunch, so I've actually moved point to its own class out here that I don't have to remake it every time I'm actually going to use this. Maybe, hopefully we'll use it again, so it's already there. So that's why that code's out, by the way. So we're going to go through and just store a list of points here, which is our dots. Then we have 2 Boolean variables, which you'll see what they're used for here in a bit. Then we go through and just go line by line in our inputs. And we are going to be doing the first part. So there's 2 parts to our inputs. There is all of the points, which are listed here. Then there is a blank new line that then separates the points from the fold instructions. So the way we flip between the two while we're doing one for loop is simply just check if the line we are at is empty. If the line is empty, we simply flip this Boolean variable here to change between the 2 loading parts. And that triggers then, if we are on the first part, so we have not reached the new line yet, we will do this logic, which is simply just to take the line, break it up, and make the points, and actually clean this up a little bit more. We don't need to do that. We can just do that right there, which is just take the input in, split it on the comma here, and grab our 2 neutral numbers and put them into a point, and then add them to our dots list here. And then for part 1, the second part, which is the instructions here. Part 1 only needs the first instruction to be complete, and then we just count up the number of dots that are on the page. But to do that, though, we still need to do the folding logic. So that folding logic is just going to become this replace here. So we just we are now on these lines here. I simply replace this initial part. It's not needed. They're all the same. So we just remove this, and we're just left with this x or y equals some number. To do this now, we just split on the equals bit, and now we have our 2 parts. The line we are folding along becomes the second part, so we just pull that out as our line here. And then we begin to go through and iterate through all of our points on the in our list. We grab the points. We do this backwards because we are going to remove the ones that are duplicated because they're just not needed, especially with part 1. We get screwed over for part 1 if we have duplicate points. We then check the first part of that instruction here for the x or the y. If it is x, we know we're folding along a column. Otherwise, if it's a y, we fold along a row. For the column here, or actually for both of them, they're both exactly the same. We check if the row or column we are at is after the fold point. If it's before or at the fold point, it doesn't matter because the column isn't changing. It's being folded, but it doesn't move anywhere. So we can ignore all the ones that are before or at the fold point. If you're after the fold point, however, we need to now fold it and kind of put it back in, or change it and put it back into our list where it will now be. We will figure out where it is we just take our column, subtract where that fold point is, and then that is our distance from the fold point we are at. Now we just need to know on the opposite side where we're at, so we just take the fold point again and subtract how far we are away. That will give us the kind of the mirrored location it is. So that's what this does. And then we just have to check now if we are in the list, because if we're already in the list, we don't want it anymore. So if this new location that this dot's going to be put at is already there, just remove it. Otherwise, go ahead and update the column of this point, and we are done with this. And that gives us the full folding logic. Nothing too insane. And then we have this. I have this check here for part 1, because after the first fold, we want to know how many points there are. So that's what this does here. It's just a kind of a Boolean flag. It starts at false. So if it's false, and we are in the second loading part, we go ahead and just output the number of dots, set this true, so that way this never runs again. So that way this only runs on the very first execution of the second part. And then once all that folding logic is done, we then go through, I find the minimum and maximum rows. That way, just to make this output logic easier, And then we just go through all of those rows and columns, go through, stripe across, just kind of command line style output this, and just go for all of the rows and columns in this. Is this row and column in our dots list? If it is, output this full Unicode block character. If it's not, output a space. And that gives us this wonderful thing here. So hopefully you guys enjoyed. That is day 13, going pretty well today. So good job, me, I guess. I don't know. But hopefully you guys learned something as well. Hopefully you guys had fun with this problem. I'll see you guys all tomorrow for day 14. Peace out.